Hello everyone. So welcome to our lecture number 19, and in this lecture we will discuss the charge on each surface of a conducting plate when initial charges are given. So our question is, find charge on each surface of conducting plate if initial charges of plate is Q1 and Q2 respectively. Okay, so as per the question, there are two conducting plates. There are two conducting plates as shown in figure, and this is your first plate, this is your second plate, and it is given in first plate the charge available is Q1, and in second plate the charge available is Q2. Yes, so we have to find charge on each surface of these conducting plates. Yes, so let's solve the question. Again, you all have to draw the diagram for answer. Now listen one thing. Let us consider this white polar part is your first side of first plate. This is your first side, this side is second side, this is your third side, and this is your fourth side or fourth surface. Yes, okay. Let on the second surface the charge available is x. Let on the second surface the amount of charge available is x. In second surface the amount of charge available as per the question, let it be x. But the total charge on the first plate is Q1, so that we can say the amount of charge available on first surface, that will be Q1 minus x. Q1 minus x. Again, now the second surface the charge available is x. So on the third surface, due to induction, minus x amount of charge will appear. Minus x amount of charge will appear. But on the second plate, total charge available is Q2. So on the fourth side, the amount of charge available will be Q2 minus x. Q2 minus x. Q2 minus of minus x. Because total charge minus charge available on third plate. So Q2 minus of minus x. That will be Q2 plus x. I hope this distribution is clear to all of you. So as per the distribution, we have assumed let on the second surface charge available is x. So on the first surface charge available will be total minus x, that is Q1 minus x. Due to induction, on the third surface the charge available will be minus x. So on the fourth surface the amount of charge available will be Q2 minus of minus x. So that will be Q2 plus x. Yes. So this is as per the distribution. So now see one thing. If you will observe this diagram, we know the electric field intensity inside the conducting plate is 0. So inside a conductor electric field intensity is 0. So let us, in the first plate, inside the region the point P is available where intensity will be 0. E net is equals to 0. But if you will see it properly, what you will observe? On the first surface the amount of charge is Q1 minus x. So the point at which we are going to calculate the electric field intensity, so we have to place a Q naught charge. So let us imagine a Q naught charge is placed at point P. Q naught charge is placed at point P. So first surface charge is positive charge, so it starts to repel the Q naught. So this is your electric field intensity E1 vector due to first surface charge. Then on the second surface x amount of charge is available, so it starts to repel the q naught. So along negative x direction, this is your electric field intensity due to charge on second surface, E2 vector. Again, on the third surface, negative x minus x amount of charge is available. That means minus amount of charge will attract q naught. So that will be the, so this is your electric field intensity due to third surface charge. Then on the fourth plate, q2 plus s, so q2 plus x amount of charge is available. That means it will repel the q naught value charge. It will repel the q naught charge. So this is the direction of electric field intensity due to charge present on fourth surface. So E1 vector and E3 vector are in positive x direction. E4 and E2 both are in negative x direction. Yes. So what we know, here we can write as E net is equal to 0. We can say total intensity on positive x side is equals to total amount of intensity on negative x side, magnitude wise. So we can write E1 plus E3 in magnitude is equals to E2 plus E4. E2 plus E4. So what is the value of E1? E is equal to sigma by 2 epsilon naught. So in this case, sigma is equal to how much? Sigma is equal to charge by area. So let area of each plate is A. Area of each surface is A. Let us think. So we can write electric field intensity is equal to Q divided by 2A epsilon naught. That means charge divided by 2 into area into epsilon naught. So for E1, the charge present on the first surface is Q1 minus x. So it will be Q1 minus x divided by 2A epsilon naught plus E3 value. Charge present on third surface is minus x, but we are taking the magnitude, so it will be charge magnitude divided by 2A epsilon naught is equals to E2 value. Second surface charge is x, that is x divided by 2A epsilon naught, so plus, then charge on fourth surface E4 value, that means charge on fourth surface is Q2 plus x divided by 2A epsilon naught. So after solving we get Q1 minus x plus x is equal to x plus Q2 plus x. So it will be minus x plus x cancel out. So remaining thing is Q1 is equals to Q2 plus 2x. So what is the value of x? X is equals to Q1 minus Q2 divided by 2. X is equals to Q1 minus Q2 divided by 2. So first surface charge is, so we can write the conclusion, charge on first surface. So first is charge on first surface. Charge on first surface. The answer is Q1 minus x, that is equals to Q1 minus x. So Q1 minus x value is Q1 minus Q2 by x. So after solving you will get, it will be Q1 minus Q2 by 2. X value is how much? X value is Q1 minus Q2 divided by 2. So after solving you will get, it will be Q1 plus Q2 divided by 2. So this is the charge on first surface. Then second thing, charge on second surface. Charge on second surface. It is very simple. That is equal to x, whose value is equal to Q1 minus Q2 by 2. Then third part, charge on third surface. Charge on third surface. That is minus x. That means minus of Q1 minus Q2 by 2. Again, fourth bit, charge on fourth surface. Charge on fourth surface. That is equals to Q2 plus x. That means Q2 plus x value Q1 minus Q2 by 2. That means it will be Q1 plus Q2 by 2. It is equal to Q1 plus Q2 divided by 2. So in a very simple manner you can remember this thing. If these are the plates, suppose these are two plates. This is your first plate, and this is your second plate. First plate total charge is Q1, second plate total charge is Q2. Small q1, let it be small q2. So how to write the charge distribution? So on the first surface, now remember this thing, first surface and fourth surface, simply we can write on the first surface the charge is q1 plus q2 by 2. On the fourth surface it will be q1 plus q2 divided by 2. Yes, and on third surface the charge value is, on third surface the charge value is q1 minus q2 divided by 2, and here negative of x, that means minus of q1 minus q2 divided by 2. This is the trick. That means you have to find, in this way we have to find the charge on each surface of this plate. Let's solve one question so that you can easily calculate the distribution of charge. Okay. Question number 1. So question is, suppose there are two plates like this. Yes. And the total charge here is 4q, here the in second plate total charge is minus 2q. So find charge on each surface of the plate. So question is, find charge on each surface of plate in following case. Find charge on each surface of plate in following cases. Yes. So how to solve this one? Now see. First, what we have to do? Remember one thing. Simply you have to add the two charges. First, all of you first add the charges 4q plus minus 2q and then divide the addition result with 2. So it will be how much? 2q by 2. 2q by 2, that is q. So simply after this, simply place on first surface charge available is q, on last surface charge available is q. Yes, but on the first plate total charge is 4q. So on one surface charge is q means this surface charge is 3q. Easily you can find 3q. 4q minus q, that is 3q. And if it is 3q, then after by induction process it will be minus 3q. This is the trick. This will be minus 3q. Now if you want to check, then check it, minus 3q plus q, it is minus q, then it is correct. This distribution is actually correct. Okay, next come to another question. Next solve another question, question number 2. Question number 2. Here it is mentioned, first surface charge is minus 4q. First plate charge is minus 4q and second plate charge is minus 2q. Minus 2q. So what we have to do in this case? Same trick, same technique you all have to apply. See one thing. First all of you add the charges and divide the addition result with 2. So minus 4q minus 2q divided by 2. That is minus 6q divided by 2. That is minus 3q. So minus 3q means simply you have to write on first surface the amount of charge is minus 3q. Sorry, in answer side you have to write on first surface the amount of charge is minus 3q, on last surface, that is fourth surface, the amount of charge is minus 3q. Then you see the total charge is minus 4q, one surface charge is minus 3q, so other surface charge will be minus q, because minus 3q minus q, it will be minus 4q. So if it is minus q, then due to induction process it will be plus q. Then you check it, plus q minus 3q, that is minus 2q. So the distribution is totally correct. Yes, I hope this question is clear to all of you. Suppose it is mentioned like this, question number 3. Question number 3. This is the question. Here total charge is q, here total charge is minus 2q, and here total charge is 2q. Total charge is 2q. So find the distribution. Yes. So how to solve this question? Now see this question properly. So what we have to do in this case? Simply add and divide by 2. So q plus minus q plus 2q divided by 2. So that is 2q by 2, that is q. So simply place this side charge is q and last surface charge is q. On first plate, if one side charge is q, then other side charge will be 0, because q plus 0 is total charge is q. If it is 0, then due to induction it will be also 0. So if the total charge is minus q on second plate, then other surface plate charge will be minus q. Now you may check by adding both these two. 0 plus minus q, that is minus q. Again, if this is your minus q charge, then due to induction it will develop plus q charge. Okay, whether it is true or false or correct or wrong, now you can check. Q plus q is 2q. We can check q plus 0, that is total charge is q, then 0 plus minus q is minus q, again q plus q is 2q. So this type of distribution is correct distribution. Again, now try to solve another question number 4. Question number 4. Question number 4, the mentioned, the given figure is this one. This is the question paper. Listen. 4 plates are there. There are 4 plates as shown in figure. In first plate, total charge is minus 3 microcoulomb. Here, minus 1 microcoulomb. Third plate, total charge is 2 microcoulomb, and fourth plate, total charge is minus 1 microcoulomb. So find the distribution of charge on each surface of plate. Yes. So again, for answer you have to draw the diagram again. So first what we have to do, this is your answer part. First simply add all these charges. Minus 3, minus 1, plus 2, minus 1 divided by 2. That is minus 3 by 2. That is equal to minus 1.5. So this surface charge is minus 1.5 microcoulomb. But total charge is minus 3 microcoulomb. So other surface charge will be also minus 1.5 microcoulomb. Yes, as this is minus 1.5 microcoulomb, so last surface charge will be minus 1.5 microcoulomb also. Again, on the second plate, on this side, left side of second plate, due to induction here the charge will be plus 1.5 microcoulomb. And the total charge is minus 1 microcoulomb. So for the second plate on right side, the charge will be, total is minus 1, one surface charge is plus 1.5, so it will be minus 2.5 microcoulomb. So minus 2.5 plus 1.5, that is minus 1. So due to induction, again on the left side of third plate, this charge will be plus 2.5 microcoulomb. But the total charge is 2 microcoulomb. So here it will be minus 0.5 microcoulomb. Minus 0.5 microcoulomb. Again, you try to add plus 2.5 minus 0.5, that is 2 microcoulomb. Again on the left side of the fourth plate, due to induction, the charge will be plus 0.5 microcoulomb. Okay, now all of you can check. Minus 1.5 minus 1.5, that is minus 3. Again plus 1.5 minus 2.5, this is minus 1. Plus 2.5 and 0.5, minus 0.5, that is 2 microcoulomb, correct. Again plus 0.5 minus 1.5, that is equal to minus 1 microcoulomb. So this type of distribution is correct distribution. Again, so come to your question number 5. Question number 5. So in question number 5, you are instructed to calculate the charge distribution. Yes. So the charge distribution, the question is as shown in figure. There are 3 plates. So first plate charge is plus 2q, second plate charge is minus 4q, third plate charge is, total charge is minus q. Again, you all have to find the distribution of charge on each surface of each plate. Yes, so what you have to do for answer, first you have to add, then divide by 2. So plus 2 minus 4 minus 1 divided by 2. Yes, okay, so it will be minus 5 plus 2, that is minus 3 by 2, minus 3q by 2, or here the answer is minus 3 by 2. So on left side of first plate the charge will be minus 3q by 2, and on the right side of the third plate the charge will be minus 3q by 2, minus 3q by 2. Again for the right side of the first plate, for the right side of the first plate the charge available will be total minus, total charge is 2q minus minus 3q by 2. So that means 2q plus 3q by 2, that is 7q by 2. So here the charge available will be 7q by 2, charge for right side of the first plate. So due to induction here the charge will be minus 7q by 2, minus 7q by 2. So but the total charge on the second plate is minus 4q, but one surface charge is minus 7q by 2. So remaining will be how much? That means you have to solve. So remaining will be total minus, so minus 4q minus minus 7q by 2. So that is equal to minus 4q plus 7q by 2. So minus q by 2. I hope it is clear. Minus q by 2. So on the this side charge is minus q by 2. So for third plate, left side of the third plate, due to induction the charge will be plus q by 2. Charge will be plus q by 2. Again all of you try to check. Minus 3q by 2 plus 7q by 2, that is total charge is 2q, that is correct. Then minus 7q by 2 minus q by 2, that is minus 8q by 2, that is minus 4q, correct. Then plus q by 2 minus 3q by 2, that is minus 2q by 2, that is minus q. The distribution is truly correct. I hope this is clear to all of you. Again come to question number 6. Come to question number 6. In question number 6, let's think 5 plates are there. Five plates are available and total charge on first plate is minus 4 coulomb, on second plate is minus 2 coulomb, on third plate is 0 coulomb, on fourth plate is 6 coulomb, and on fifth plate is minus 2 coulomb. So find the distribution of charge on each surface of plate. This is our question. So in order to solve the question, draw the diagram. So this is our diagram. For answer you have to draw the diagram again. So the trick is, first all of you add the charges. Minus 4 minus 2 plus 0 plus 6 minus 2 divided by 2. Minus 4. So let's think this is your 4 coulomb. Let us consider this is your 4 coulomb. Here it is plus 4 coulomb. Let's think this is plus 4 coulomb. So this is plus 4. So 4 minus 2, 0 plus 6 minus 2. That means this is equals to 4 minus 2 is 2, 2 plus 6, 8 minus 2 is 6. 6 by 2, that is 3. So on left side of the first plate, that is 3 coulomb. On right side of the last plate, that is also 3 coulomb. So what for first plate? Let's think for first plate. One surface charge is 3 coulomb. Total charge is 4 coulomb. So other surface charge will be 1 coulomb. So due to induction process, on the left side of the second plate, this is minus 1 coulomb. But the total charge is minus 2 coulomb. So on the right side, the total charge will be minus 1 coulomb. So due to induction, here plus 1 coulomb will be there. Yes, but the total charge is 0 coulomb. So on the right side of the third plate, here it will be minus 1 coulomb. I hope it is clear. So due to induction on fourth plate, it will be plus 1 coulomb. But the total charge is how much? Total charge is 6 coulomb. One surface charge is plus 1. So remaining, so right side of the fourth plate, it will be 4 coulomb. Then on the left side of the last plate, that is minus 4 coulomb due to induction. Now check. Sorry, here on the right side of the for fourth plate, one surface charge is 1 coulomb, total charge is 6 coulomb, so it will be on right side of fourth plate, it will be 5 coulomb. So here it will be minus 5 coulomb. Okay, minus 5 plus 3 coulomb, that is minus 2 coulomb. This is the distribution. Now you all can check. You all check this answer. 3 coulomb plus 1 coulomb, that is 4 coulomb, correct. Minus 1 coulomb minus 1 coulomb, that is 2 coulomb, true. Then plus 1 coulomb minus 1 coulomb, that is 0 coulomb, correct. Then 1 coulomb 5 coulomb, that is 6 coulomb, correct. Minus 5 plus 3, that is minus 2 coulomb, that is also correct. This is as per the distribution process. Okay, first all of you add these charges, after that you can solve. Yes, so for last question, come to your last question, that is question number 7. 4 plates are there, suppose 4 plates are available. Yes, total charge is minus 5 coulomb, and here it is 8 coulomb, here it is 4 coulomb, and on fourth plate, that is 3 coulomb. So find the distribution of charge. I hope this is a very very simple question for all of you. So for answer, you have to draw the diagram again. Then minus 5 plus 8 plus 4 plus 3, minus 5, then plus 8 plus 4 plus 3. So what will be the answer? Let us think the second plate charge is given 6 microcoulomb. It is 6 microcoulomb or 6 coulomb, suppose 6 coulomb. So in answer part, you have to write minus 5 plus 6 plus 4 plus 3 divided by 2. That means 6 plus 4 10 plus 3 13 minus 5, that is 8 by 2, that is 4. That means on left side of the first plate, the charge is 4 coulomb. On right side of the last plate, the charge is 4 coulomb. Now come to first plate, right side. The total charge on first plate is minus 5 coulomb. Here one surface charge is 4 coulomb. So remaining will be minus 5 minus 4, that is minus 9 coulomb. Total minus 4 coulomb. Then due to induction on left side of second plate, here it will be 9 coulomb. But total charge is 6 coulomb. So remaining right side plate, right side of the second plate, 6 minus 9, that is minus 3 coulomb. So due to induction on left side of the third plate, here it will be plus 3 coulomb, and total charge is 4 coulomb. So on right side of third plate, that is your 1 coulomb. And due to induction on left side of the fourth plate, here it will be minus 1 coulomb. Now all of you try to check. 4 coulomb plus minus 9 coulomb, that is minus 5 coulomb, correct. Then 9 coulomb plus minus 3 coulomb, yes, that is 6 coulomb, that is correct. Then 3 coulomb plus 1 coulomb, that is 4 coulomb, correct. Then minus 1 coulomb plus 4 coulomb, that is 3 coulomb, that is correct. So I hope the distribution of charge, the tricks related to the tricks behind this distribution of charge due to these conducting plates. So it is clear to all of you. So if you think that this concept is helpful for you all, then kindly like, share and subscribe this channel, and please share this video to your friends. Okay, so thank you, have a nice day.